Alright, we're going to use the trigonometric ratios to find the unknown sides and angles in the right triangle below. Let's first of all look at the given angle. The given angle, or our reference angle, is 60 degrees. So let's label what we know from the given angle. We know that 10 is opposite. We know that y is the adjacent side, and we know that x is the hypotenuse. So now let's set up the trig ratios that we're familiar with. If we want to solve for x, I see that I'm going to look at the opposite over the hypotenuse. So that is the sine. The sine of 60 equals 10 over x. When I solve, 10 divided by the sine of 60 tells me that x equals about 11.5. Now let's solve for y. To solve for y, I'm going to use the tangent because I have the opposite over the adjacent. The tangent of 60 equals 10 over y. When I plug that into my calculator, 10 divided by the tangent of 60, I find out that y is about 5.8. Now I'm going to look at angle B, and I'm going to determine the sides from angle B. If I try to find the measure of angle B, first of all, since I'm finding an angle measure, I know I'm going to have to use an inverse function, and I'm going to use the opposite over the adjacent. So that's a tangent function. So the inverse tangent of the opposite, which is actually side y, 5.8 over the adjacent 10, and I find out that my angle measure is about 30 degrees. Alright, let's look at the next one. Alright, I'm going to do the same thing. I'm going to look at my reference angle. My reference angle is 45 degrees. So I'm going to identify the side that is opposite. I'm going to identify the side that is adjacent, and I'm going to identify the hypotenuse. So if I wanted to solve for x, I have the opposite over the adjacent. That's a trig function, tangent. So the tangent of 45 equals the opposite over the adjacent. That means 3 divided by the tangent of 45 equals x, and I find out that x equals 3. Next, I'm going to try and solve for y. I have the opposite over the hypotenuse. That is the sine function. The sine of 45 equals the opposite, 3, over the hypotenuse, y. Y equals about 4.24. Now let's look at angle A. I'm finding the angle measure, so that means I'm going to use the inverse function, and let's use the adjacent and the hypotenuse. So adjacent and hypotenuse is cosine, so I have the inverse cosine of the adjacent side, which is 3, over the hypotenuse, which we discovered was about 4.24, and that's going to equal A, which we find out is 45 degrees. Let's try the next one. Alright, again, I have a right triangle. I'm going to start with my reference angle, 53.4. I'm going to identify the sides. This is the opposite of the reference angle, adjacent, and hypotenuse. So if I wanted to solve for A, I could use the opposite over the adjacent. So I have the tangent of 53.4 equals the opposite, A, over the adjacent, 5.6. So here I'm going to take both sides of the equation and multiply by 5.6. I find out that A equals about 7.54. Now let's look at solving for C. To solve for C, given the measure that I have of the adjacent, I have the adjacent and the hypotenuse. Adjacent and hypotenuse is a cosine function. So the cosine of 53.4 equals the adjacent, 5.6, over the hypotenuse, C. Well, 5.6 divided by the cosine of 53.4 is about 9.39. Now I have to find angle B. So let's look at angle B. When I look at angle B, I know the opposite, and I'm going to use the hypotenuse. Opposite and hypotenuse, that is the sine. I'm going to use the inverse function, so the inverse sine of the opposite, which is 5.6, over the hypotenuse, which we discovered to be about 9.39, equals B. I find out that B equals about 36.6 degrees. All right, we only have 3 more. Let's keep going. All right, so here we do not have any angle measures given to us with the exception of the right angle. So the first thing that we're going to have to do is use the Pythagorean theorem. So we're going to Pythag this. So I have 7 squared plus 8 squared equals C squared. 113 equals C squared. The square root of both sides, I find out that C is about 10.63. So now let's find angle A. I'm going to do the opposite over the adjacent. That's going to be the inverse tan. The inverse tangent of 7 over 8 is going to equal A. And let's set up B really fast. B is also the opposite over the adjacent, so we're going to use the inverse tan of 8 over 7 to equal B. So going back to my calculator, the inverse tan of 7 divided by 8, I found out that A is about 41.2 degrees. The inverse tangent of 8 divided by 7 is 48.8 degrees. Okay, let's look at number 5. Number 5, again, same exact thing. This is actually a typo. It should just be 86. This is the number 86. That's the measurement we're going to use. So I am going to label my sides. So from the angle given, I have the opposite, the adjacent, and the hypotenuse. So let's first of all use the sine function. The sine of 43.9, sine is opposite over hypotenuse, is going to give me B over 86. And then solving for A, that's going to be the cosine of 43.9, which is going to give me A over 86, the opposite over the hypotenuse. So when I put this into my calculator, I'm just going to take 86, multiply it by the sine of 43.9, and I find out that B equals about 59.63. And then I'm going to take the cosine of 43.9 and multiply that by 86. And when I do that, I find out that A equals about 61.97. Okay? Then to find the angle measure, A, I'm going to use the opposite. Let me erase some of this. For A, I'm going to use the opposite over the adjacent. Opposite over the adjacent. I'm finding an angle measure, so that's going to be the inverse of tangent, or the arctan. the opposite, which was A, 61.97, over the adjacent, which is B, 59.63, and I find out that A is about 46.1 degrees. Okay, we have one more example, and that's it. Alright, for this example we're finding the value of x, and this one is a little bit tricky just because there are two triangles overlapping each other. X is just the remainder or the difference between the two missing sides. So I want you to first of all look at the large triangle. I'm trying to outline it in red. So if I just look at the large triangle, I'm going to call this missing side y, and I am going to say that I have the opposite over the adjacent, so the tangent of 40, because my large angle is 40, is the opposite y over the adjacent, 87. I'm going to multiply the tangent of 40 by 87, and I find out that y equals 73. Now I want to look at the smaller triangle, and I'm going to outline this in green. For the smaller triangle, I have an angle measure of 25, and we're going to call this missing side z. So for the smaller triangle, I have the tangent of 25, still the opposite over the adjacent, z over 87, and I find out that z equals, alright, so I see that z equals, I'm going to multiply both sides by 87. The tangent of 25 times 87 is actually 40.6. So then to find x, I'm just going to subtract the large side, y, minus the short side, z, and that's going to give me what's left over. So y minus z equals x, and 73 minus 40.6 is about 32.4. So that means x equals about 32.4 feet. That's a tricky one, but as long as you divide it up into two triangles, you can see how to work the math. And that's it. Good luck.